Hello. So today what I'm going to do is I'm going to go over Chapter 10 in Chris Odom's book, um, on physical computing with Arduino. And this is a really dense chapter. It's taken a long time to actually kind of work through it myself to come up with these examples and type them all in. And I've come to the conclusion I simply can't do it all in just 15 minutes. So I'm going to split this into two different videos. One on just the while loop. The other one is going to be on the do while loop and then a little bit of a conclusion. Um, so before we just jump into it, let me give you a little bit of a foundation here. I have a new piece of code here, a new sketch. I've got the basic stuff set up here. I've got my serial port open. I'm waiting until the window is open. My computer is particularly slow that I'm doing this on, so I'm going to kick in an extra half a second just to make sure. And of course we've got our main loop. And in the main loop, I'm going to let us know we're starting by printing out starting examples. And of course I'm going to break it into a new line with the switch statement. And then when it gets to the bottom of whatever we do in here, it's going to let us know that we're entering the infinite loop. And as soon as it types this out, it does in fact enter an infinite loop. This is a while statement you've already seen. And it's going to enter this while true, and it's never going to escape, and it's just going to stop. Okay. This video, because I'm going to try to compress it, you're going to see lots of pauses, but I'm going to compile this right now and pause. And of course, it did exactly what you saw before. But what I do want to show you ever so quickly is that if I just throw a bunch of these things in here, that in fact it is going to do all of these in sequence, then do this, then enter the infinite loop. So let's just go ahead and recompile it. And you can see it did exactly what you sort of expect. Okay, it gave us the starting examples, it gave us the new line, and entered the infinite loop. And of course, the computer is still working away. It's just stuck in an infinite loop, and we're not going to see any more output. So let me clean all this up and get the first example up, and I'll see you in a second. So why I wanted to show you that little thing before about proving to you that in fact it hits this infinite loop is that here you see I've written a new while loop, okay? And you see that we have a while true, and basically instead of, as Chris's example, flashing a light, I just have it saying on, off, and you can see it scrolling down on, off. But it's never actually making it to this particular section of our main loop. Well, that's because there's no escape, okay? We have a while true in here, and instead of it just being an empty while true, like this one, we have a while true with some function going on here, some activity. It's typing on and off. But there's no escape, okay? So here we're going to see this thing just go on and on and on and on until the power goes out, okay? This is it. This is its entire existence. And it never allows it to go down here. Now this is an important point. It never gets here. It gets stuck in this while loop. So let me pause this and load up another example, and we'll talk a little bit more about it. Before I totally move away from this, I do want to show you one other kind of cool thing. There's more than one way to do this while true statement. In fact, there's several. And here's a couple examples that are in the book. For example, right now you can see it's running, and I have it's while it's not false. All right. Well, that's sort of the same thing as not true, or as true. If I went ahead and did this one, while 1 is equated to 1, you would expect, well, I mean, 1 is 1. I mean, so it's going to be stuck in an infinite loop until 1 somehow changes from 1 to something else. So you're going to expect to see it work the same way. Much like this example down here. 1 is not 2. Well, if 2 ever became 1, well, then it would stop. But 1 is not 2, so we have it stuck in an infinite loop. I also want to mention here, see this one is a singular line, okay? This is a while statement, all right? I could put an optional statement on the back of here, make it do something else. But most of what we're going to be dealing with are called blocks. So you can see the curly braces that are going to include the functions that we wish to cover. So after that, let me go ahead and load this next example, and I'll see you in a second. Now here I have an example of a while loop that has a conditional expression in here that we need to talk briefly about. So, and following this through is an important concept. I've created here a variable. It's a byte, okay? We're calling it counter is equal to 0. And while counter is less than 5, it's going to then display the counter. It's going to then say, well, the counter is now equal to the counter plus 1. And then we're going to see a delay. And it's going to loop back and forth for as long as it's less than 5. So we start with 0. It's going to be a 1, a 2, a 3, a 4, on and on. And in this particular case, okay, you can see that we haven't, it's going to end. It's going to reach a point where it says, well, it's no longer less than 5. And we should, of course, see it enter this thing here where it enters the infinite loop, and now it's stuck. And lo and behold, when I run it, that's exactly what I have. Okay, example 2. And it counts up 0, 1, 2, 3, 4, and then it enters the infinite loop. So why did it not go to 5? All right, I said it went, all right, well, counter is less than 5. So at some point here, it hit 3, added 1, 4, it still passes, displays the 4, adds 1, now 5. Now watch this, okay? We never actually see it reach 5, but let's say I simply take and control and move this equation to in front, all right? So now we're going to add 1, then display it. So if I run this, you should see that this is going to change ever so slightly. 1, 2, 3, 4, 5. Okay? Well, that's because it added it, then displayed it. Then when it came up, it was now a 5, and it exited out. Okay? In the other case, when we had it below, it didn't add it until after. Okay, I'm sorry. Yeah, it didn't add it until after displaying it. So by simply watching the sequence here, it will change your output, and this is very important. So let me end this for the moment, and I'll see you in a second. Okay, so on this next block, what we've done is we've done something very similar to what we did before, except now my byte, I'm going to have it go all the way up to 254. So as long as it's less than or equal to 254, it's going to display the value, it's going to add 1 to it, and it's going to delay. And you just watch it scroll right up to 254. And it did probably exactly what you thought it should. It went ahead then and exited this while statement and went back to the main loop, and it entered the infinite loop. Okay, super, it's working perfectly. So let's change this now to 255, all right, and see what happens. And you think to yourself, oh, it should just scroll right on down to 255, and it should enter the infinite loop. And lo and behold, it zips along here. We see it flying along. And, whoa, what the heck? Okay, it never actually entered the infinite loop. It's stuck in its own loop. Well, that's because, if you recall, a byte can only go to 255. We're adding it after the value, okay? So we display it, and then we add 1, which means that inside of here, it's actually reached 256. Well, 256 is actually 0, okay? So it goes back and resets itself, and it goes over and over and over and over, and it never gets to exit this loop because it never actually gets there. All right, kind of cool. Let's move on. So on this next set here, I'm actually going to combine a few of the examples in Chris Odom's book. So it's well worth it for you to at least take a quick look at the individual bits. But for the sake of time, I'm going to combine these a little bit. So here you see what I've actually done is I've taken and put 2 while statements within this function. And you can see here what it's doing is it's counting up by 5, and then it should exit it once it gets to a value which is still less than 100, and it jumps down to the next while loop. And I'm now counting down by 10s. So you see it goes 0, 5, 10, all the way up to 100, and then it starts counting down by 10s. What I want to show you now is a couple other little things. For example, I can, if I'm going to count up directly by ones, I can actually do something really simple. I can just put in plus plus, and in here I can put in minus minus, all right? And let's actually make this times a lot smaller so we don't have to wait too long. So this is going to automatically increment by 1, and it's going to automatically decrease by 1. So if I run this, we should see these numbers be the same. I'm sorry, they shouldn't be the same. I'm not counting by 5s anymore. But you should see it scroll rapidly up to 100 and then bound back down. And here we go. We hit 100 and we bound ourselves back down, and it exits the loop. Let me pause this and change a little bit more, and I'll be with you in a second. So now what I've done is I've created yet another sort of shortcut here. You can see that I have counter plus equal 3 and counter minus equal 7. So this is a shortcut way of typing out the counter is equal to counter plus 3 or counter is equal to counter minus 7. I've changed these values so it goes real quick, but you see what it's done here. It's went 0, 3, 6, 9, 12, 15, 18, 21, 14, 7, and 0. And then, of course, it entered the infinite loop. So let me change this up again, and we'll show you another example. So in this example, I was going to use it for a couple of things. One is to show you that floats work just as well. So here we are. We're going to count all the way from float x equals 0 all the way up to pi, and we're going to display it with 5 decimal points, and you can see that I'm adding 0.00001 to each case, and it finally reached it and it hit 3.14. Notice I don't have any kind of delay in here. That took a little while. All right. The other thing which is kind of amazing is to realize just how long it takes to actually print. So let me run this again, except I'm not going to print, and we'll wait to see the infinite loop. So now we're not going to get any of this. We're just going to look at the time it takes from loading to done. Okay? So that difference in time that you just perceived right there was entirely because you were printing. This can be a really significant factor when it comes to when you're actually working with a real moving robot. If you end up printing all of your data all the time, it can seriously hamper its ability to read sensor values or smoothly power its servo motors. So just remember that. Printing is extremely important. It's awesome for debugging, but don't always assume that you can do it without any effect. So let me pause this. So here we have a geometric progression example. Another example of the ways that we can increment and decrease our while statements. In this case, you can see we're actually multiplying, all right, and we're dividing. So a nice shortcut here, way of doing it. And you can see it did probably what you predict, 2, 4, 8, 16, 32, and then it does its reverse to work its way down. Once it has completed both of these tasks, it exits both of these while statements and goes to the infinite loop in our main loop. So let me show you something else. So in this case, what we're going to do is we're actually going to use the while loop to increment 2 variables. We can have multiple variables going. So we have I, which is going to be incrementing by 1, and we have x, which is going to be incrementing geometrically. And you can see we've used those 2 variables to display a nice sort of table here, where we're printing out I, which is going to be used as the counter, and we're going to be using x for our data. Once it's completed its task of keeping it less than 2,000, it exits the while and enters the infinite loop. Okay, now we're almost out of time, so I'm going to hurry here. Well, I've come to the reality that I'm not going to be able to completely finish this while loop section in 15 minutes flat. I've only got 34 seconds left. So I will make a very short part B to this, and I'm sorry, it looks like it's going to creep over to a couple of videos, maybe 3. So I will see you guys again soon.